So for problem 1, we're going to take all of the values and we are going to add them together and then divide by the total number of values in the data set, which in this case was, we were told at the very beginning, was 10 students. So we'll divide this whole thing by 10, and that's how we're going to find the mean for this first data. And that's what the X bar stands for, is the mean. That's just a formal term. Okay, that's what problem 1, part A is going to look like. For these first, going over these first 3 problems, so for the mean, you can just show me your setup, like this is what the mean's going to look like, and then we can go ahead and actually calculate it. Whoops, and what did we end up getting for the mean for problem 1 here? The mean came out to what? I didn't actually run the numbers on it. Anyone get that?
I got 4.82.
4.82? All right, that sounds good to me. So 4.82. Okay, and then finding the value of P, just like Ashley already suggested, that is the median. So it's just a it's just a way of finding the median. And to find the median in the data, we could just go halfway down the numbers. So they're 10, 1, 2, 3, 4, 5. It's going to be halfway between 3 and 5. So P should be 4.25. You can add 3.5 and 5 together and divide by 2. That's one way to do it. And then to find your interquartile range, that is something that will be given to you on the IB exam, but I'm going to ask that you guys have that memorized for this one because that's a pretty easy formula. We're just going to take the Q3 minus the Q1. In this case, 8 minus 3, 5. That's what the interquartile range will be. On the IB exam, on these written problems, very important to show your steps. If you get graded for showing your work and the answer, so you can get like, if the problem says like on the side it'll be worth 2 points or something like that, usually you get 1 point for the work and 1 point for the answer. So make sure you're showing your work. And it's also really important because if you make a mistake on the work, they can still give you partial credit. Like sometimes there's like a 4-point problem and they'll give you 2 points if you have the work, but then you made a small mistake on it getting to your answer. So they can give you some follow-through points. So very important on those types of problems. I think number 1 is pretty straightforward. Number 2 and 3 dive into a little more difficult when we're talking about these IB problems. All right, so number 2, a data set has n items. Okay, the sum of the items is 800 and the mean is 20. The standard deviation of this data set is 3. Each value in this set is multiplied by 10. Okay, so that's gonna mess things up. So first, part A, we need to find n. So we know it has n items and the sum items is 800 and the mean is 20. So think about, how do I calculate mean? That's kind of what our hint should be. I'm gonna take the sum of all the items and I'm going to divide by the number of items. Well, I already know that the mean in this problem is 20. So now I'm just solving for n. That's where part A comes in. So the IB exam, they're gonna love to give you questions with like a weird spin on it. So like, hey, everybody should know how to do mean. That's pretty straightforward. But what happens if I give you the mean and I'm asking you to work backwards from there? That's what the IB exam loves to do. This is like a classic IB question, something you could really expect to see on their exam. So in this case, we multiply both sides by n. We get 20n equals 800. Divide both sides by 20. N equals 800 divided by 20. So n equals 40. That would be our n value. So there are going to be 40 items. And then part B says write down the value of the new mean, and that's because each value is multiplied by 10. So if we multiply each individual value by 10, what we're really doing is we're multiplying the total by 10. So even though we don't know what the individual items are, we do know that we can multiply the total by 10, and that's going to give us 8,000. And then we would say, okay, well, 8,000 is the mean. We're dividing by 40 items because the number of items stays the exact same. And we should end up getting 200. So our new mean is 200. I can probably change colors, make it a little easier for you guys, but yeah. And then the last one, find the value of the new variance. Variance was something we talked about briefly. I just kind of covered it and moved on. But how do you find variance? It had something to do with the standard deviation. Do you guys remember? It was actually just the standard deviation squared. So if you're ever looking for variance, you just take the standard deviation and you square it. So the original standard deviation was 3. What do you think the new standard deviation is if we're multiplying each value by 10? Any guesses? It's going to be 3 times 10. 30.
How is that squared though?
What'd you say?
How is that squared since it's just the standard deviation? Since the standard deviation is 3?
So the standard deviation of the original data set was 3. So 30 is the standard deviation of the new data set. It's not squared.
Is that squared?
Not yet. So what happened is that's the standard deviation of the new data set. So in order to find the variance, we need to square that value. So the most common mistake you'll see on this problem is people will use 3 and square it and get the variance is 9, but the variance is actually going to be 900. Okay, so just remembering where you are in the problem, even if you came up with a variance of 9, bless you, and you show the IB exam this step, that counts for partial credit. So again, as long as you're showing them you know what variance is and you might have gotten a little messed up in the problem along the way, that's perfectly fine. But that's how these problems work. Okay, they kind of ask you to work through and think about that type of stuff. So as long as you show I know what the variance is, but I might have used it wrong on this particular problem, that's perfectly fine. You'll still get partial credit. All right. All right, and then problem 3, I'm going to give you guys a couple minutes to work on it now. So first part for part A says just find the range of the data. So the range you have to recognize goes from min to max. Okay, and it says the range is 16, so you'd say a minus 8 equals 16. Add 8 to both sides, a equals 24. All right, and again, this is a 2-pointer, so that means you get 1 point just for writing down the answer, 1 point for showing the setup. So make sure you guys are trying to show your setup. If you're actually taking the IB exam, you want to practice as you play, and make sure you are showing the setup properly. Interquartile range, that's where you need to recognize your Q1 and your Q3. So IQR is Q3 minus Q1. In this case, that's 20 minus 15. So we get 5. Okay. Part C, find the mean number of hours that the girls in this group spent watching television that week. Okay. So the mean number of hours, that was where we said there were 10 girls and 180 total hours. That was all in the data up here. I highlighted that. So we would just say 180 divided by 10 equals mean, which comes out to 18. So they averaged an average of 18 hours a week. And then find the total number of hours the group of boys spent watching television that week. So we know that their mean was 21, and we know there were 40 of them. So 21 equals 40 over the total number. And then we would just say 21, or was it, there weren't 40 of them, I'm sorry, there were 20 of them. So we do 21 times 20, and we would end up getting 420. So that's where you just, again, show your setup, and then you can show your work from there. The next one, find the mean number of hours that all 30 girls and boys spent watching television that week. So we know the boys spent 420, the girls spent 180, and then we divide by 30, and that's going to give us the new mean. And I think it came out to 600 over 30, so it comes out to 20 hours.
Can you slow down for a sec?
Slow down, sorry, yes. Going way too fast on you guys. I apologize. But yeah, that's the idea. Let's take a look at part F. So the mean number of hours that the group of boys spent watching television. So this is the new one after their exams. And again, it doesn't specify very well here. But we already know the old mean was given, so it's got to be the new one now. And we would say it's going to be 21 divided by 2, which is 10 and a half. That's the following week because they had exams and they spent half as much time watching television. That's where we got that information from. And then the last part, the variance in the number of hours the group of boys spent watching television. And again, this is another IB problem where we saw the original standard deviation was 3. Let me fix that. We'll say the original standard deviation in green was 3. So the revised standard deviation's got to be cut in half. So we saw that 2 problems in a row, which obviously those were not on the same year IB exam, but they like asking this variance question. So it's easy points if you know what you're doing. So cut that in half. That's your new standard deviation, and then you want to square that value to get your variance, which in this case should be 2.25. That's the idea for part G there, the last problem. But yeah, just asking about variance, square the standard deviation. Even if you write down variance of standard deviation squared, that's going to get you 1 point no matter what, even if you have the wrong numbers and everything else. You get 1 point just for writing that part down. Super important there. Okay, so those first 3, like I said, real problems from the IB exam. Problems 4 through, let's see, well, these are kind of tight together.
F and G, is it okay if we're a little confused on that?
Is it okay if you're a little confused on it? Yeah, the wording is kind of sneaky on this problem, so I think that makes it tough. But yeah, also, I mean, like I said, this is actual IB exam questions, so this is the hardest it's going to get, right? Especially when you get to the bottom of those IB questions, they do get tougher. So that's why I kind of put them in order of 1, 2, 3, because I think number 3 is definitely the toughest one of all of them. But yeah, and the wording's not very good. It should be like, what's the new mean for the number of hours for the boys? And then you could say, oh, I take the old mean and I'm cutting it in half. That's how I get the new one, because they had exams this week. Yeah, just really weird. Okay, now we got problems 4, 5, 6, 7, 8, 9. Okay, so I got a few more problems here. I'm going to let you guys go ahead and work on these at your own pace. And just let me know if you're stuck on something or if you guys want to see an example together. I'm more than happy to go through something with you guys. But these are just practice problems. What I did was I wrote the test yesterday first, and then I went back and created the practice. So that way we can try and match up test to practice. That was really my goal there. So I'm really not trying to throw any huge curveballs at you on the test itself, to be frank, right? If you guys are good on these practice problems, you should be okay on the test on Monday. So please go look through and work on these problems right now, and let me know if you have any questions. If you guys want to work on them together, that's fine with me. this is a good, number 5, part A is a good example of continuous data because we're measuring, not counting. Now it says, if the mode is 17, find the value of x. So I'm looking at my information here and I see there's one 17, there's another 17. So there's two 17s in this data. But I also see, hey, wait a minute. I see a 24 and another 24. So technically this thing could be bimodal, which means there are two modes, but it doesn't say that. It says there's one mode and it's 17. So that means one of our numbers, x or y, has to be 17. That's kind of the trick for part B. Okay, because it has to be 17, so that way this becomes the mode. So that's what x is going to be then. And then when we're finding the median value for part C, we should reorganize our data. So 16, 17, 17, 17, then we had a 19, 20, 20, oh, see, so there was a 20 as well, there were two 20s. So that's why 17 would have to have 3 spots. And then 22, 23, 24, 24, 25. And there's also the y that's somewhere in this data set as well. But we don't know where the y is. We just know that we need to say there are 13 tulips, so we need to get to halfway through them. And we know find the median value that way. Okay, so 1, 2, 3, 4, 5, 6. It's going to be between 20 and 20, it looks like. And even if we added a y value, if we added the y value on this side, it'd be the 7th point in, which would be the first 20. If we added the y value on this side, it'd be the second 20. So the median is going to be 20 no matter what. That one's kind of a weird one, even though we don't know what the y is yet. Okay, that's how we'd find part C. And then part D, if the mean is 21, find the value for y. So now we're just calculating that we know the mean is 21. We know there's 13 data points, and we need to find the total. Okay, that's going to give us 21 times 13. And 21 times 13 equals 273. And since we have 273 for our total value, we can literally subtract every single number until we get to our y. And that's how we would find the value of y. Which comes out to what in this case?
29.
29? Yeah, okay. Yeah, that one's kind of a tricky one, but that's another classic IB question where they're going to expect you to use the mean and the median and the mode in a different way. Okay, so that one's a tricky one though. So let me record this. So to find outliers, you're going to do IQR equals, and then you would do Q1 minus 1.5 times the IQR. That's what it was, sorry. So it was Q1 minus 1.5 times the IQR. It's not going to be IQR equals. And then that's going to give us the first value. That's the lower limit. And then to find the upper limit, it was going to be Q3 plus 1.5 times IQR. So you got to do your interquartile range. So identifying that 5-number summary is very important for this problem. So we have our min, our max, our median, our Q1, and our Q3. All right. What was our min for this problem? Was it 9? Yep. And then our max was what? 30... 40, was it? 41. Perfect. 41's our max. And then, yeah, this works at best if we reorganize the data first. So we're going to do 9. We'll put 41 at the end there. And then I'm going to do my 10s, which is 12, 16, 18. And then organize my 20s. So we're going to do 22, 23, 23, 25, 26. Oh, we have two 25s. And then we had a 26, 26. I missed a 22 back there. Dang. Okay, so it's 22 over here. And then I have 31, 31, 37. So I get my data organized from min to max. And I know there's 16 pieces, so the median's going to be halfway between 1, 2, 3, 4, 5, 6, 7, 8, 9. So the median looks like it's going to be 24 because it's halfway between these two. And then quadrant one is going to be like take these 8 and find halfway between the first 8. 1, 2, 3, 4, 5. So it's going to be between 18 and 22. So Q1 is going to be 20. And then Q3 halfway between the second 8. 1, 2, 3, 4, halfway between 26 and 31. So Q3 is going to be, what is that? 28.5, yes. Okay. So then to find our min and max to identify if there's outliers, you're going to do 20 minus 1.5 times whatever your interquartile range is, which is 8.5 in this case. So 20 minus 1.5 times 8.5. And it comes out to 7.25. So turns out 9 is definitely in there, so 9 is not an outlier. And then when we do Q3, 28.5 plus 1.5 times 8.5. 0.5 plus 1.5 times the 8.5, bam. And we get 41.25. So by the skin of its teeth, 41 is in there. So there are no outliers on this data set. Okay, that's how this one would work here. And we got about 10 minutes left. We got 2 problems left on this set, 8 and 9. Problem 8, what we did yesterday, draw a scatter graph of the data and then describe the correlation. Okay. On the Go Formative on Monday, I'll probably just have it multiple choice for describing. Is it going to be strong positive, moderate positive, weak positive, strong negative, weak negative, moderate negative? You know, I'll probably do something like that. Okay, and then problem 9, frequency table, complete the cumulative frequency table, and then sketch the cumulative frequency curve, and then we're going to identify information from the curve. Okay. So I do have problem 8, part A, the graph is done. And then describe the correlation. It's definitely negative on this problem from left to right. You can see it's going down. And I would say that's pretty weak correlation. I mean, you can't really draw a line straight through that. I can kind of draw a line right here, but I'm still going to have a lot of data points that aren't close to that line. So I would say that's weak on the data. I might accept moderate as well, but definitely not strong correlation on this one. Okay, and again, if I do multiple choice and I think it's kind of iffy, I'll just click both of them, say I'll accept negative and weak and negative and moderate as my answers. Okay, definitely negative correlation though. All right, problem 9, complete the cumulative frequency table. So that's where we add all of the values up. One of the nice things is over here on the right side of the table, I put 100 down here, which is the total for 100 people. So if we do the cumulative frequency table right, this number should be the exact same. That should be 100 down there. And we're going to add the values up. We start at 6, and we add 22, so we get to 28. And then we say 28 plus 34 is going to be 52, right? No, it's 62. 62 plus 22 is 84. 84 plus 12 is 96. 96 plus 4 is 100. So that's how we would complete our cumulative frequency table. And then we sketch the curve. So from 0 to 5 is going to be 6. So time in minutes up to 6, it looks like. We'll start at 0 there. And then when we get to 10, we go to 28. And we're using the cumulative frequency for our table here. When we get to 15, we're all the way up to 62 now. When we get to 20, we're at 84. At 25, we're at 96. And at 30, we're at 100. And then we just sketch our line that goes through those points. That's kind of what our cumulative frequency curve is going to look like. And then we're going to find the median. And the median would be halfway through our frequency. So we would guess the median's probably about 14 minutes. And again, on this type of problem, I'd probably give you multiple choice if I was asking you about median or something like this. All right. And so there will be some multiple choice on the test. There might be some show your work answers. Like if I have you do a graph, it'll be show your work. If I'm having you fill out a table, show your work. All right, those types of things. The interquartile range means we're going to go from the 25th percentile and the 75th percentile. So we're going to look over here, and that'll be our interquartile range. And just something to keep in mind, right now this is nice because our sample is 100. If our sample was like 80 instead, and this only goes up to 80, remember you have to do like 50% of 80 is 40. Okay, so you'd find the middle at 40, and then 75% of 80 would be 60, so you'd find the 60 and you'd find the 20. So you have to be able to work with percentages in case the frequency is not 100. That's a hint for the test on Monday, that this frequency might not be a nice easy 100 to work with the percentiles. Okay, the interquartile range is going from, it looks like about 9 to about 17. So 17 minus 9, so it's going to be about 8. Okay, and then the 85th percentile in this problem we're going to find. 85th percentile is going to be at the 85. And we had 84 at 20, so we could say it's about 20 would be fine. Okay. Okay, that would be your 85th percentile for that problem. All right, your assignment is page 141, chapter review, and I picked some random problems, or not random problems, but I picked some problems from the assignment that I think would be helpful. But honestly, if you want extra practice, there are plenty of good problems in there that I skipped over as well. You can just look at those ones. I just didn't want to be repetitive on the problems I was assigning. That was kind of the goal, part of the goal. But I think they're going to be good practice for you guys.